Hello everybody, this is Reese Codes and I'm back with another video. We're going to go over some more mathematical symbols and then how you can translate that into code. So right here we have our example equation. This is not an equation that is tied to anything in real life, but this is just as an example to show as many mathematical symbols, new mathematical symbols that we didn't go over in the previous video, so we can have something to work off of. So for this particular example, we have a concept called vectorized pricing. And we're going to say let P be a vector of n dimensions, and P is going to be equal to this. Usually when you have a vector, it's shown in this kind of notation. So you see P1, P2, P3, all the way to Pn, and n meaning how many dimensions you have in the vector, which is how many elements you have basically. And we're going to say P represents prices rounded to the nearest dollar. Okay, all elements of P to N are going to be inside the natural number set. This is what this funny looking N right here means. It means everything is going to be within the natural number set. Natural numbers meaning anything that is a whole number, 50, 75, 1, 2, 216, just whole numbers, no decimals, no negatives. And then we're going to have let W be a vector matching P in dimensionality. So what this means right here is that W and P are going to be the same length. So if P has 5 elements in it, W will also have 5 elements in it. The elements of W, however, are going to be different than P. They're going to be randomized, and they're going to be between 0 and 1. So we have these parentheses right here. This is basically putting limits on what the set is. So the set now, before the set was all natural numbers, so that's N. Now the set for W is going to be between 0 and 1, excluding 0 and 1. So it'll be 0.1 up to 0.999. Then we're going to have mu right here. It's going to equal P dot W. So usually, this would mean like a multiplication, because a dot can also mean multiplication. When you're dealing with vectors, it means there's a specific operation called the dot product, and that's what that means right here. So this we're going to do P dot product. We're going to do a P dot product with W, and then we're going to get mu. And then we have the vectorized pricing function, so that's VP, and we're going to take in the mu value right here, and this arrow basically means this is what that function is. And here we have, this is capital Pi, and what capital Pi means is we had capital sigma before in the previous video, and that meant we're going to add all of these elements together, right? We're going to add all of these elements together, and whatever was in this section was what we were going to add together. So for this, what this is saying is n equals 1 all the way to n. We're going to take every element in P, multiply that and multiply them together. And that will be this number right here, this top number. The bottom number will be a division between mu, which is what we passed into this function, and E squared. So E is another, this is one of those kind of constants like pi, and it's called Euler's constant, and it defaults to a certain number. I forget what the number is, like 2.7 something, I don't know. But that is a constant. So we're gonna raise this constant to the second power, and then we're going to divide that by mu, and that's going to be this bottom number here, and then we're going to divide all that together, and then that will be our vectorized pricing. So let's go to the code, and we'll see this. Okay. All right. So first things first, we're going to do this in C++. I remember in the last video I had said we'd do an example in Python. We'll also do an example in C++. So right here, we're just kind of setting ourselves up for things to come. We're going to have our vector length of 3 because we're going to be taking prices. Let me go back a little bit. We're going to be taking prices from here, from this prices.text, and we're going to be inputting those to make our vector P. So P is going to be full of prices that are inside of this, text file. So we're going to take the text file. We'll go ahead and read in the values from the text file. We'll place those values inside of this temporary variable called price from file, and then we will input it into this vector that we made with eigen. So eigen is a C++ library that is used to do a lot of linear algebra equations. And when you're dealing with the dot product, you want to use one of those kind of libraries. The dot product is not something that is in the standard math library, I think in C++. So this right here, this eigen vector xd, this means just a vector of any kind of length. So we had the length here, we set it as 3. We'll loop through the file for 3 times to get these 3 prices right here. Now you may be wondering why these prices these are whole numbers. These are not whole numbers. These are decimals. These are 1200.00, 200.00, 139.00. Natural numbers are not supposed to have any decimals. That's true. But when you're dealing with C++, we have to make the types same if we're going to do operations on them. So because our W vector is going to be a decimal. It's going to be between 0.1 and it's going to be between 0 and 1, and all of those values are decimals. So we have to make, for the purposes of our program, we have to input this as decimals, but this right here is the part that we're really concerned about. Is this is whole number, and there's no zeros, there's no values right here. It's not like this is 200.10 or this is 1200.70. These are all zeros, so this works out fine. This is just for type purposes dealing with C++. All right, so we got our price list. So we have price list here that represents P. That's P right there. Now we're going to go ahead and generate W. So we declare W. W is the vector of 3 because remember, P and W in this equation have to have the same dimensionality. So dimensionality is 3. P is length of 3. W is a length of 3. We go through for loop and we generate a random number, which is through this function right here. In the distribution, we're going to do a uniform real distribution, and it's going to be between 0 and 1. And so then we get that random number back. And so now we've generated, so by line 32, we have generated P and we've generated W, and they all fit the criteria that is with this equation. P is all natural numbers, and then W is all decimals between 0 and 1, values between 0 and 1. Now let's go ahead and generate mu. We have mu here. We're going to do price list dot W. That is a method that is on these eigenvectors. You can do a dot product with it. So we got a dot product that equals mu. Now we want to go and multiply all of the vectors, all of the elements, inside of P. Now the way I did this, because in math, elements start at 1. In computer science, in math, vectors start at 1. There's element 1 in this vector, there's element 2, element 3, and so on and so forth. When you're dealing with computer science, though, counting starts at 0. So there's a mismatch there. So if I had n equals 0, and I did P0, that's not going to map to anything that's in P. There is no P0. There's P1, P2, P3, etc. So to handle that discrepancy, we put the total as 1 right now, and then we'll go through and loop, and then we'll add whatever's in the price list by 1. So that really takes care of that discrepancy right there, because otherwise we couldn't be able to do it. So we'll go ahead here, we'll get the total of this top part right here. So this is the product of all of the elements in P. And then we have mu. So we'll output these two values. And now we'll go to the actual, division of the two pieces, right? We have this value, and then we're going to generate this value, and then we're going to divide them. And that right there is how we do that. So this right here, standard EXP, this is what I was talking about, that E value, that is a mathematical constant. That's like pi. That is just a thing that is just known. And when you see that symbol, that's what you're supposed to put in there. So there is, in the standard library, there is a method to figure out that. So if you want to, in this EXP right here, and so what this will do is this will take the Euler constant and then raise it to the power of 2. So that's what we do there. We'll divide that by mu, and then we'll divide that value by the total that we got through the product of all of these elements. And then we'll output the final value, vectorized pricing of what this equation is supposed to do. So let's run it through here real quick. Oh, hang on, that's not right. This is concerning.
Oh my God, bro. Oh, hell no, man. What the fuck, man? Get your ass on.
Let's build this again. It's not even saying the prices are the, that's not the, hang on. I think I have to pass wrong here. There we go. I had to pass wrong. Okay, so let me clear this out again. We'll do that again. Okay. So we can see right here, we have the price list, 1200, 200, 139. We have the W list, the W vector. List is a concept they have in Python. I was thinking about Python when I was making this. It's fine. But that corresponds to the vector. So this corresponds to the P vector. This corresponds to the W vector. We get a total here. And then we get our value mu. And then we go ahead and divide that 2, and then we get our final answer right there. And like I said, the values here, they're randomized slightly. Definitely W is randomized. So you're going to get different values here and there. So that's one right here that kind of, it's not a scientific notation answer. But yeah, that's how we do that. I hope that this video had elucidated some kind of things as far as demystifying math and how it relates to code. When you see these, and these are just some caveats here too. Usually vectors are bold small letters. So when you see a bold letter like this in your math, scientific paper, whatever, equation, those are usually vectors. Sometimes they'll put this notation down there. Sometimes they won't. It depends. And but when they talk about dimensions of P or PV in a vector or whatever else like that, it's usually going to be bold. This notation right here, the product notation, sometimes this is funky. Latex is a little bit funky sometimes when you put this on top of a division symbol. So sometimes it comes out funky like this. Usually this n equals 1 is going to be underneath the product right here, and then the n is going to be on top, and then this p in whatever you are multiplying, the expression that you're multiplying by, you're doing a product of, is going to be right there in the middle. And then I think the last thing I would probably say is this arrow notation that sometimes is done to denote the function, but then sometimes they won't do that as well. So, it's up to them. But I hope everyone had a good time learning about this, and I think the next video we're going to do is we're going to go and do some real world examples about doing this math and different contexts of how it can be applied. So I think next time, I've been reading a lot about decentralized finance, so I think we'll do an example with decentralized finance. And I also think the next time we do another one of these kind of math symbol breakdowns, we will take one of these papers that one of these decentralized finance exchanges are working with. They usually publish like a white paper or something like that to kind of say this is how we're going to be handling the crypto and whatnot. And so I think we'll go through one of those papers, and then we will go pluck out the equations, and then we'll do a hybrid sort of library. I'm thinking maybe in JavaScript, because I haven't done that yet. So we'll the next video will be taking a real world example this time, and then we will translate that into a C++ JavaScript hybrid library that we can use in Node.js. Thank you for your time.